Hello, my name is Nicole Schill from exactEarth here in Cambridge, Ontario, and I'll be your host today. I'd like to start by saying good morning or afternoon to everyone who's joined us, and we appreciate you giving up your time to explore Satellite AIS technology. We assume you've joined us because you've heard something about Satellite AIS or exactEarth and would like to learn more about the technology and what we here at exactEarth are doing to set ourselves apart in the industry. So this webinar is the third in a series of webinars we'll be hosting aimed at educating people about Satellite AIS. So today, in the next 30 minutes, we'll explore the revolutionary idea behind Satellite AIS Data-on-Demand as we take a closer look at the new product offering from exactEarth, exactAIS Geospatial Web Services. I'm joined here today with Graham Stickler, our Senior Director of Global Marketing, and Carl Putty, our Technical Analyst. Graham will walk you through the basics of web services and how they apply to the world of Satellite AIS. Then Carl's going to take you through a brief tour of what we've been doing here at exactEarth to put those geospatial web services into action. Before we begin, just a small favor we ask is that if you have microphones, to please mute them for the duration of the webinar so that everyone can hear us clearly. And if you have any questions throughout, please use the chat window to submit them, and we'll reserve a few minutes at the end to try and answer as many as we can. Also, please use the chat window for any technical issues you might have, and our team will work to resolve them ASAP. So it looks like we're ready to get started, so I'm going to hand things over to Graham Stickler to guide you through the exciting world of web services. Graham?
Thanks, Nicole. Hello, everyone, and welcome again to the third webinar in our Satellite AIS information series. I'd like to start today. I'm going to give you a little bit of background for those of you that perhaps missed the first two webinars we've done, on a little bit about what we do here and why it's so important for us to release these geospatial web services to the community. So maybe a little bit of background. I think, as we all know, the oceans are a vast environment, a huge portion of our planet. 70% of our planet is blue, and we may already have our own idyllic views of the ocean in our own minds. But I think it comes as no surprise to any of us that the world's oceans are in fact not empty. They are very, very busy, and on any given day they support the weight of hundreds of thousands of small and large vessels, container ships, passenger liners, tankers, cargo ships and the like, providing a vital link in the world's economy. So such traffic volumes really present a sizable navigation, monitoring and tracking challenge, and knowing who is on the water at any given time and where they are headed is not just essential to trade but also to maritime safety, and it's certainly one of the most challenging questions that we come across in the maritime world. We've reviewed in our earlier webinars how we can make use of the AIS technology that's currently employed on the world's major shipping to provide a picture of the global movement of ship data. To give you a very quick recap, as you may well know, under the SOLAS Convention, all major vessels over 300 gross tons, all carrying passengers, carry this AIS technology and are constantly transmitting information about themselves and their movements to those around them. We can see here, for example, the sorts of information that's being broadcast on these AIS channels, and we can pick these information up and listen in as we've described in the previous webinars. So as you will know, exactEarth have a constellation of satellites that are orbiting the planet in low Earth orbit, and we listen into these global AIS transmissions and we collect the data, and the number of satellites in the constellation is increasing over time, allowing us to ever improve the rate at which these data flow to us and on to our customers. And this 24/7 service that's now in operation is currently processing somewhere in the region of 5 million satellite and coastal AIS messages per day from over 100,000 ships that are constantly moving about the ocean surface. And sometimes what is we tend to forget is we've been doing this for over 3 years, and that really is a lot of data. We're talking perhaps somewhere around 500 million AIS messages over that time, and a huge amount of important information on over 300 million different vessel positions, giving us a quite unique insight into the world's ship movements. So our traditional method of deploying these data is something we've termed the AIS hosepipe. We collect all of this vast amount of AIS information, we get it down from the satellites through a data processing center, and we effectively stream these AIS messages at our end users in as near real time as we can manage it. And if we look at what this means to our customers, here's a good example. Here's a typical day in the North Atlantic where we see a huge number of ships sat out in the ocean. I sometimes like to refer to this as the North Atlantic haystack. A huge amount of information that arrives at the customer's screen, and really it's very difficult, certainly visually, to understand really what's going on. And what we've found over time is that a lot of our users are much more interested in certain amounts of that information if they've got their own needles in this haystack. Here's a very, very simple example you can see here where we have filtered out just those ships who are transmitting a valid AIS message but they don't have a ship name. And this may be very important to certain people to understand, okay, these are a set of ships that I need to go and investigate more closely, as why aren't they broadcasting a valid ship name? But the point is there's been a filter applied to give us some intelligence to help us make the next step in our decision-making process. So really we have three challenges with this traditional approach. One, as you will have seen, there is a huge amount of data being passed around. Secondly, perhaps more importantly to some, the AIS message structures are sometimes very complex, and a lot of our users don't really understand them or don't need to. And the third is the interoperability issue, one coming from having a particular format of AIS message, and secondly the fact that everybody has their own preferred method of looking at these data. They are very much location based, geodata if you like, and so therefore a traditional method would be to look at them on a map, but everybody has their own way in which they may want to look at that data. So our challenges really are, can we look at traditional and advancing IT technology to try and address those things like cloud delivery, delivering data across the internet, allowing for M2M services, machine-to-machine talking, rather than users getting in the way, having people take the data, get their needles out of these haystacks, using computer communications. And then thirdly, kind of related as well, is the whole aspect of self-service or on demand, which means I ask for the data I wish, my own needles maybe, if you like to think of it that way, and I only receive back, instead of huge data volumes, I only get back the data that I'm really interested in at the time that I'm interested in it. So really the way in which we do this is we're taking the very, very traditional approach of web services, but in this case they're geospatial web services because of the location component. And I thought I'd just spend a very few seconds here on the technical aspects of what a web service is, in case it's new to people. But web services are essentially software components that you make available across the internet. It's something you can interact with. They're reusable in the sense that they sit there and they wait to do their task as instructed, and they're made openly available for people to interact with them. And you can embed these web services calls inside software applications and even website pages. And maybe the best way of introducing these is, I suspect most people in their lives will have used these whether they know it or not, maybe for getting an insurance quote. If you've gone to a website where you've put in your information about getting a particular insurance quote and you've had the website go off and search all the insurance brokers to bring you back the best deals. The ways in which that has been done will be a communication of web services. The site in which you've entered your information has polled out to various different other sites on a web service environment, received the information that they've particularly asked for, and just got that information back and then collated it and presented it all to you. And in some ways we're doing very much the same thing here. So web services, really, the main characteristics that are important for us is they're available over the internet. They use a standardized message system, which is important, which means it gives us the interoperability between all different systems. And they're not tied to any one operating system or programming language. They're entirely independent of that, which obviously means people are free to build applications and systems in their language or operating system of choice and still interact with these web services. The diagram on the right gives you some sort of conceptual idea. On the right hand side we effectively have the web service. The web services publishes itself in terms of a service registry on the internet. This means that we can find it, and we can find out the characteristics about the web service. Having discovered the web service and how it works, we can then interact with that web service as a client and ask that web service to do whatever the web service was set up to do. In our case, to deliver us vessel information. A quick look at the architecture that supports this, and this may hopefully make things a little bit clearer. If you look at the bottom of this diagram, we still, as per normal, are taking data in from various sources. Here we're showing the satellite and the coastal AIS data, and we put it into the data processing center. And now the big difference is, rather than just put this data then straight out in an AIS message format to our end users, we take that data into a relational database system. And this is important because, one, we're storing the data, but two, we do a very important step here is we transform the data. We transform it from an AIS message structure into what we call a vessel-centric model. And that is more logical for people who don't understand AIS. What that basically means is we take all the AIS messages, we put them all back together and relate them all to a single vessel for that particular point in time. Having created that vessel-centric database, what we then do is we employ a web server and build the web services to make that data available in a standard form across the internet for people to interact with. And we allow people to interact with this data really in two different ways. One would be in a read or view only mode, which is termed a WMS or a web map service. And in this form, if I make a request of the web service for a certain amount of data, what I will get back is physically a map display that I can then use and embed and view and query in my client application. The other way of doing it would be to access data as a WFS, a web feature service, and in this form the GWS itself will return me data, physically return to the client the data I've asked for, and then in a standard form, maybe as XML or KML, and then I have that data on my local machine and I can choose to do whatever I want to it. So how have we structured the web services that we provide? We've really offered two core services. One is the latest vessel information, and the second is historical information, and I'll quickly walk through those. So the first latest vessel information means we're providing a web service to allow you to pull down the latest vessel position and latest information of all the vessels in the database. And we look back over a 90-day period, and the last vessel information that we have for every vessel is made available to the user. The historical vessel information is really split between two. We have the historical vessel positions, HVP, and this is over a 90-day period, all the position reports and associated data that we have received for that individual vessel. And then historical tracks is where we will take those position reports and actually create a vector from them, so you end up with a 90-day track of that vessel's movements. All of these different products have the ability to filter, going back to the original premise of not wanting all the data. When we query these web services, we can pull back data based on our own parameters. So for example, I may only want to pull back the latest vessel information for all tankers that are flagged to Canada. Or I might want the tracks of just those vessels that have gone more than 20 knots in the Straits of Gibraltar. So I've got various ways in which I can parameterize up my call. I can get this information back, again, getting back my needles from the very, very large AIS data haystack. And here's the best bit, is that we've taken the trouble as well in producing these web services to make sure that they conform to the OGC standards, and in fact they're certified to the OGC standards. If that means nothing to you, then the Open Geospatial Consortium, the OGC, is actually an international industry consortium that develops the public standards for the geospatial world. And if you like, you can think of them as the ISO of the geospatial world. So what does this mean for us? It means that the services that we produced are guaranteed to meet the interoperability challenge that we talked about at the beginning. It ensures that our web services are compatible with all the geospatial platforms and clients. So Esri, for example, Google are probably the most common, but you can even download now free map viewers from the internet that will conform to the OGC standards and will just accept and view our web services as called. And in fact, you can even draw these basic web services into a blank web page if you so choose. So just some examples here. Here we have some latest vessel information coming out of the web service directly into a Google Earth client. And then following on from that, we can look here at an Esri ArcMap client with the same web service being drawn. And we've also added to that a track. So anyway, that's enough of the theory. And I think it's time we saw this in action. So I'll hand over to Carl, who's now going to show you how we can make use of some of these geospatial web services in a live environment. Carl.
Okay, thanks, Graham. That was great. So, as we said, our services are OGC certified solutions, and we've now offered exactAIS data that is compatible with the desktop. This enables clients to overcome data interoperability issues and integration issues that would otherwise foil attempts to share and exploit marine vessel intelligence. Geospatial web services are out-of-the-box compatible with Esri software, including ArcMap and ArcGlobe, and many more. The specially developed ArcMap 10.1 add-in enables users to take full advantage of geospatial web services by providing an easy-to-use interface to add and create filters, as well as identify and generate historical tracks, making the integration of exactAIS data even easier. Using a set of drop-down menus, users can choose how to style, color, and filter the GWS latest vessel information layers and add it to the map. The add-in also includes a built-in tool to identify geospatial web service information using the Get Feature Info tool. Users can click on any vessel or historical track to display its name, position, and destination information. Now we're going to switch over to ArcMap and explore exactAIS geospatial web services through the easy-to-use add-in tool. Here we see we've got the Geospatial Web Services menu, we have the Get Feature Info and Get Feature Data tool that we're later going to come back to. First, what we're going to do is we're going to select from this drop-down the LVI layer, and we're going to make a request to our service, and we can choose how to style the layer. We'll just give it a name, EELVI, and from this style we're going to choose by type. We can also choose by speed or just by vessel color, but we'll add this by just clicking the add button. As we're at a global extent right now, this is going to basically fill the map with all of our positions, and any pan or any movement that we make is simply a new request to our LVI layer service. Now we're going to zoom in, pan around, all making new requests. So each time this is pinging out to our server, and we're getting a return based on the area that we've selected to. What we're going to do now is we're going to use the Get Feature Info tool, and we're going to click on some of these vessels in the window. Here we see the Luxandra. Looks like it's flagged to Liberia. We see the Chembulk Savannah, and this one over here is the Norwegian Dawn. That's flagged to the Bahamas. We can see each of these vessels, we get their unique information, the last position that this vessel had, all of its information such as the IMO, the MMSI, the call sign, the time, and of course its position, speed, and all the information that it has passed through to our service. Something that you notice at the bottom of the Get Feature Info results dialog is a couple of buttons. We have the Add Track here, and we're just going to click this, and this is going to add us a track of the last 30 days where this vessel has been. We're just going to turn off the LVI layer, and now we have a track that we're going to pan around and we're going to see where this has been. Now each pan here again is making a new request to our service, and we're getting a return of the data that is created by that MMSI. we're going to use the Get Feature Info tool, and we can click on any point along this track and receive the data and information that the ship has passed through at this point in its journey. So we can see the time has changed here and the speeds are different. So next we're going to use the Get Track button, which basically makes a request to our web feature service. So it's returned a track shapefile that is from our web feature service. As you can see, it lines up exactly over top of the track that we have. So these buttons go after the web feature service, and they basically return the data in the form of a shapefile. And here you can see that we can use the Identify tool and find out the information about this. Now we'll just show the get points. So this has gone out to our web feature service and requested that we receive all the points from this vessel. And now we can see with the Identify tool the information about them. What we're going to do now is we're going to set up a filter from our service. So we're again going to make a request to the latest vessel information. We're going to call this one Canadian Vessels. So we know the range of MMSIs that have been assigned to Canada, and we're just going to set them in the filter here, and we're going to add this filter to our web service request. And this will return a set of vessels, once we add it to the map, that are flagged only to Canada. We see here they're mostly around Canada. We're just going to turn off the full LVI, and now we'll zoom over and zoom in a little bit more. And we see most of the vessels are close to shore. They're not really too far out there, but we're going to identify some of them with the Get Feature Info tool again. So this request that we've made is a pre-set up layer that we've effectively created, and now we're making requests to it with the Get Feature Info. So all of the vessels here are flagged to Canada, and you can see that as we scan through these. Now what we're going to do is we're going to use the Get Feature Data tool. This is going to be the last thing we show in our demo here inside of ArcMap. And we're going to perform a Get Feature Data request with this tool on the latest vessel information layer. So we're going to just outline an area here, and we're just off the northern coast of Brazil in the mid-Atlantic. And we double click with this tool, and what we see is a series of points that have been effectively returned as a shapefile, and they go into our menu here labeled LVI. And much like the Get Points and Get Track requests that we made before, we can see here we've just made a Get Points request to the LVI service, and we've returned a shapefile from our web feature service. We can go through and click on all of these with the Identify tool and find out the information about them, when the points were, how fast the vessel was going at the time, and etc. So that concludes our demo inside of ArcGIS's desktop environment, ArcMap. We're now going to switch over to a web page that has been built around our Geospatial Web Services to interact with our data in an online environment. This is called ShipView. Again, we have our latest vessel information web map service layer displayed, and each pan of this map and zoom is a separate request made over the internet to interact and request new data from our web map service. So as we zoom in here, we're going to click on some of these vessels again to just simply show their information. Here's the Universal Antwerp, the Bicam Houston, and the Nodos. We have built in a search option to search for vessels by common attributes like name, IMO, MMSI, and call sign. Here we're going to search for the McKinney, which is the largest ship in the world right now. and we see here are the vessels that have that name. It's going to be this one here, the Maersk McKinney Mauler. And we can see where this vessel is at the time in our latest vessel information. We're going to click on it, and we can see it's flagged to Denmark. Now we're going to use the scroll bar feature at the bottom here to request from the HT layer, our historical track layer. We're going to go through some increments of time and see where this vessel has been. Right now we're just showing 15 days, and it looks to have come from China. And now we can go back even further, all the way up to 90 days. But at any point in time along this journey, we can see what the vessel has done, how fast it was going, and basically all of the information that was passed through to our satellites. Here we have 45 days of track, and it looks like it's already doing its same route again. So we're now done with the McKinney Maersk Mauler. We're now going to create an OGC certified filter of vessels traveling less than 5 knots. We can select from a list of available attributes. In this case, we're going to choose speed, and we're going to say that it's less than or equal to 5 knots. We will give just a name. We'll call it slow ships. And we'll choose a custom color. We'll make it blue. And we will leave the style as just vessel. When we add this to the map, this is effectively going to make a machine-to-machine request where we have a web map service that is pre-set up that we can go after, similar to our Canadian vessels, if you remember from the last section. And now we can see all of the ships in the oceans that are going less than 5 knots. We'll just zoom in and we'll click on some of these. This is the Dar IHN. And here is the Evergold #1 from the Seychelles. As you can see, this could be very useful information to know. It's obvious that a lot of ships around port are going to be going very slow, but you have ships in the middle of the ocean that are going slow, and you may want to know why they're doing that. So this is just a simple piece of intelligence that we've requested to our web map service, and we've been returned this as a separate layer that we can now go and move amongst and find out some more further information. Anyways, so that's going to wrap up our demo in ShipView with this last bulk China here. As we see, it stopped basically just off the coast going into the Straits of Malacca. So anyways, in short, we have shown applications that have been developed to interact with our geospatial web services in the desktop and web environments. The ArcMap add-in gives the vast Esri community access to our web services in a free environment where interoperability issues are minimal. The options don't stop here, as geospatial web services are fully compatible with Google Earth and KML, as well as other GIS viewers and tools. As you have seen, the global community is easily reached with web applications and development like ShipView. And that's going to conclude our demo section for today. I'll now pass you back over to Graham and further on to Nicole.
Okay, thanks Carl, that's great. And I hope everyone's seen there how easy it is to ingest these web services really within any type of geospatial platform. We've seen very easily there, whether it's a sophisticated GIS client or a simple customized web page, how the geospatial web services can allow us to understand and get a picture very quickly about the who and the what and the when of ship traffic, either globally or within a specific area. I think we've also very neatly demonstrated there how using web services we get access to data on demand, Carl showed very neatly how we can qualify the data we look for and only receive back that data that we're interested in. The example of very slow or stationary ships may well be our particular needle in the haystack that we're looking for, and we take away with web services a lot of the pain and understanding of what that data set looks like right from the start. And from an interoperability point of view, we've seen very much that it doesn't really matter what geospatial platform we use, from the very sophisticated to the very simple, to interact with these web services. So how do you start with geospatial web services? Well, we've tried to make that as easy as we can for people. Obviously, we have this webinar series to help introduce it. We also have created a website called the exactEarth Gallery, and we would encourage people to go to this website where you will see further examples of the sorts of data that can be accessed from web services. It gives you a very simple viewer on the web to interact with these web services, very much like the ship view application that Carl just showed you. But more importantly, that it will give you some sample web services to interact with yourselves. It'll allow you to start playing with web services and understand for your own benefit how you can incorporate these into your systems and business processes. And we would really recommend you look at those. For those of you out there, many of you I'm sure are using Esri platforms. We have an Esri version of this gallery on ArcGIS Online. I'm sure many of you have already started the new journey in looking at this exciting internet platform. And if you have, please search for us on ArcGIS Online, and you will find a very similar approach there, where there will be sample data that you can view within the ArcGIS Online map template, and also information on how to connect to the web services yourself from your own client, and again allow you to explore and build your own picture. So maybe I'd just like to quickly sum up what we hope to have shown you in this webinar about geospatial web services, which have really moved us into the area of data as a service, or DAS as it's commonly called. And what we're really looking for here is to open you up to on-demand and what you want and when you want it data, to protect people from the vast data volumes that are out there, to remove the need for additional database hardware, infrastructure, ways of storing these millions of messages, database administrator, high-end servers. Really, we're taking away that in the true tradition of essentially cloud computing, and saying we exactEarth here will now host all the data for you. We will make that data fully available to you in a very flexible standards format for you to extract that data as and when you want it, and allow you to connect to this data then from any geospatial client, from a GIS, heavy-end GIS, or as you've seen, even just from your browser, and away you go. And it really is that simple. So in conclusion, I hope you've got something out of this webinar, and you have now a good appreciation for what we can do with geospatial web services, and more importantly what you can do with access to these geospatial web services. And so I'll hand back now to Nicole to sum up.
Thanks, Graham. I think that was a great webinar, really covered a lot of things, but we did have a few questions that came in through the webinar, so we're going to try to get to as many as we can. If we don't have time today to answer your questions, we will follow up with all of you after the webinar ends via email. So we did want to tackle some of them. Graham, question 1 asks that you mentioned the web services being OGC certified, which sounds great. But if you're using Esri, how will this work within Esri Map and Feature Services? Are they the same thing? Okay,
that's a very good question. Obviously, we've got some technical people in the audience today. So the answer to that is they are not the same thing. The OGC obviously have a standard set of services, as I said, web map services, web feature services, and there is an Esri flavor to those, if you like, called Esri Map and Esri Feature Services. What I think you will have seen from the webinar is that by providing our data in an OGC standard, that an Esri client can read them and can work with them, as Carl has very clearly demonstrated. You can't do everything with an OGC web service in an Esri client that you can with an Esri service, but you will have seen very clearly that they are compatible. And for us to make an open standard for everyone to use, we obviously followed the OGC route for that. However, having said that, we can support Esri feature and Esri map services. We are able to do that, and are more than happy to do that for customers if they request it, and if you get in touch with us, we can certainly talk to you about that. And also, I would say, is obviously the data in ArcGIS Online, which I mentioned briefly at the end there, will allow you then to take that data away from the ArcGIS Online platform in an Esri format that meets your needs.
Okay, so I think we're going to end on that note. We do want to thank you all for joining us today. And if you do have any questions about GWS or any of our other products and services, please visit our company website at www.exactEarth.com. There's great downloads on there, lots of stuff about web services that you can learn about there. So thanks everyone for joining us today, and we'll see you next time.